Hello and welcome to Lenset, a channel for intelligent and curious people like you who are searching for human sexuality, psychology in the age of artificial intelligence. And in this channel, we talk about human and robot partners, artificial intelligence, artificial general intelligence, AGI, and of course, the artificial super intelligence, ASI, which will be a kind of super exciting moment in our technology field.
Come on, slowpoke.
Before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support. Now, in my previous video, I talked about the sensory world of humanoid robots. And that in that part one, I talked about the proprioceptive sensors. Uh, and in this part, I will talk about exteroceptive sensors. This is also a kind of sense of world. And while proprioceptive sensors give a robot self-awareness, exteroceptive sensors are its window to the outside world. That means these sensors gather information from the environment, enabling the robot to navigate, interact with objects and people, and make sense of its surroundings. So let's dig deep into it. Exteroceptive sensors are broadly categorized in four parts. Number one is vision systems. Number two is LiDAR or light detection and ranging. Number three is auditory sensors, that means microphones. And number four is tactile sensors, which we also call it artificial skin. Because whenever you get touched by someone, when someone touches you, you feel, isn't it? Either you feel good or bad, that's a different thing, but you feel something, isn't it? So, same thing happens for a robot. It also feels, right? When you touch a robot, holds its hands or touch something else, it feels. Okay. So let's dig deep into from the first part, the step one. That is, it starts with vision system. Of course, a robot doesn't have eyes like us. It has cameras. Now the question is, what kind of cameras and how these cameras work? Just as vision is a primary sense for humans, cameras are the most critical exteroceptive sensors for humanoid robots. Why? The reason is simple. Most humanoids robots are equipped with stereo cameras. That means two cameras apart like human eyes. Imagine the situation, or if you have a robot, you can just check it. It is placed in their heads. Two separated cameras, just like eyes, placed on their heads. This setup provides depth perception, 3D, 2D, what? It These sensors, these cameras actually, vision systems, gives them a kind of self-awareness, the depth perception. It allows the robot to judge distance to objects. That means how far it is, how far you are from it, which is essential for navigation and manipulation. Now we know that why this navigation and manipulation are very very important. Now advanced vision systems use sophisticated algorithms for object recognition, face tracking, scene understanding, and many things more. I'm not going to elaborate because I have a plan to, of course, elaborate in some other videos about these vision systems. There are a lot of things, to know if you really want to know about know your robot partner, and they can identify a cup on a table, your hands, your legs, or something in between, and recognize your face, differentiate between a doorway and a solid wall. Some robots also incorporate 360-degree cameras to maintain a complete awareness of their surroundings without needing to constantly turn their heads. That is fantastic. That means we, we cannot see our back, isn't it? We don't have eyes in my the backside of our of my head, but a robot can watch their back. It's like a little bit ghostly. It sounds a little bit scary, but it happens. Now we come to light detection and ranging, that what we also call LIDAR or LiDAR or LiDAR or something like that. It is often seen as a spinning cylinder on a robot's head or torso. This LiDAR works by emitting pulses of laser light and measuring the time it takes for the light to reflect off surrounding objects. That means if you stand in front of a robot, the robot sends a laser light, the laser light hits you, comes back to the robot, and gives it a perception of how distant you are, how far you are. This process generates a precise three-dimensional point cloud map of the environment. So LiDAR is exceptionally accurate at measuring distance and is less affected by poor lighting conditions than traditional cameras, because traditional cameras usually miserably fail in poor lighting. We know that. So it is the cornerstone of autonomous navigation, allowing the robot to map its environment, avoid obstacles with high reliability, and localize itself within that map. So this light detection and ranging is very, very important for human and robot partners. Next comes third part, auditory sensors or microphones. To interact with humans naturally, robots need to hear, of course, and it needs to hear from different sources, not from only you, from also from other sources to detect that sound. So arrays of microphones over their body allow them to detect the direction a sound is coming from. That means a sound localization, we call it. It enables the robot to turn and face someone who is speaking to it. Like a robot looking this way, someone speaks from its right side. So it turns away its face and looks towards that person. It's incredible, simply incredible. It is, isn't it? So advanced audio processing allows for speech recognition, so that robot can understand and respond to verbal comments. So all the verbal communication happens here, and it's a factor, very important factor for the robot to have these auditory sensors or microphones. And microphones can also be used to detect environmental sounds, as I said, such as an alarm or a doorbell or a door is opening or closing, providing additional situational awareness. Finally, we come to tactile sensors or artificial skin, where the magic begins. Why? Because touching is something that plays a very crucial role in any kind of intimate activities. If you think about something else with your robot partner, then this tactile sensors really, really, really plays a very important role. And an emerging and exciting area in robotics is the development of artificial skin. These are flexible sheets embedded with dense arrays of pressure and temperature sensors. I will talk about this pressure and temperature sensors in separate videos, because these are so nuanced subject, so uh, specialized subjects that they need special attention. and it covers a robot's fingers, hands, and other parts of its body with tactile skin, and it provides a much richer and more human like sense of touch than isolated force sensors. It can detect not just how much force is being applied, that means when you grab a robot's hand or something else, it feels the pressure you are applying, but also its distribution, texture, and temperature. This would allow a robot to handle fragile objects with greater dexterity. And it also detects a slip and interacts with people more safely and gently. So, this is the story of the sensory world of human and robots, part 2. Hopefully, we'll come back with the separate stories of vision systems, light detecting and ranging systems, auditory sensors, tactile sensors later. So, that is it. Thank you for joining us on this journey. Let's continue this conversation in the comments below. If you like the video, please hit the bell icon to get notified, and don't forget to like with your friends, share, and subscribe for more insights. If you have already subscribed, tons of thanks for your support. It means a lot to me. And please consider signing up for membership zone to support Wooden Slate so that we can make it better and better. See you in the next video. Till then, goodbye. Take care and stay safe.